First is introduction of bridge. A bridge is a spanning structure which allows the road to pass through obstacles such as waterway, highway, and railway. A bridge is a structure of wood, iron, concrete, and others that serve to connect two places separated by other structure. To build a structure, designer need to understand the concept of tension and compression. These features are the most important element to enable the bridge to ladder. Structure mechanics. Structure mechanics is an analysis of study of the properties and behavior of a structure when it is subject to a lot of force. The force is divided into two types, which is the internal force and the external force. First, external force. External force can be related to the load imposed on a structure. It covers the width of the structure itself and the external load imposed on the structure. A dead load is a permanent force acting on a structure, while a live load is variable or non-permanent force acting on a structure. This includes wind strength and the wave object inside or above the structure. Second is internal force. Internal force is the force present on a structure material to withstand the applied load. An internal force acts in the opposite direction to an external force or a force holding an object together when an external force or other load is applied. Internal forces are sometimes called resistance because they resist the effect of external force. This force produces an internal force or pressure in material from which the structure is made.
Hi, Assalamualaikum. So here's my part. As you can see, this is our group bridge design model using Limpro software. I designed the model according to the specified specification. Overall length of the bridge is 10 meter. The clear span between edges of supporting abutment is 8 meters. The overall width is 2 meter and the overall height is 3 meter. This uniform distributed load on bridge model is 2000 kg or 2 tons for overall length of this bridge model. I using I-beam on size universal column 305 x 305 x 283 mm for all member bridge. After the bridge design model were done, the data analysis from the Limpro software will be collected.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Arina Shafika binti Marzuki and my matrix number is AP190254. Here I would like to present our group project. This is my part draw final model showing plan and elevations using AutoCAD. Okay, first of all is figure 1, which is front view of the bridge, and figure 2 is plan view of the bridge. For your knowledge, overall length of the models is 10,000 millimeters or 10 meters. For clear span between edges of supporting abutment be 8000 mm or 8 meter. Figure 3 is side view of the bridge and figure 4 is 3D model structure of the bridge. Maximum overall width is 2000 mm or 2 meter and maximum overall height is 3000 mm or 3 meter. Figure 5 is front elevations of the bridge and figure 6 is side elevations of the bridge. So that's all from my part. Thank you.
This is our bridge. Aerostatic analysis. View the movement. This is movement. This is a shear force. This is the tensile force. This is deflection line. And this is pressure. And this is the calculation of
My name is Muhammad Amirul Hakim bin Harizan. My matrix number AP190134. So, for the manual calculation, there is 4 manual calculation, which is first is calculate the determinacy of thrust. The formula for this calculation is M equal to J minus R. So, as we can see here, M equal to 21, J equal to 12, R equal to 3. So, we will get the calculation is 21 equal to 21, which is the thrust of this bridge is statically determinate or stable. Next, we move to calculate the UDL forces of bridge project. So, as we can see here, this is our bridge project that has been cut to the forces area only. So, for the outer bridge, for forces is 19.61 kilonewton, and for the inner forces is 39.22 kilonewton. And for the calculation is for the joint B, I am using 19.61 kilonewton times 2 equal to 39.22 kN, and I apply this the same calculation for joint B, C, D, E, and F. So for the all joint, we get the same forces, which is 39.22 kilonewton. Next, we move to calculate for each support reaction A and E. So as we can see here, the crucial things that we need to write is Fx equal to 0, Fy equal to 0, and M equal to 0. So the first one is MA equal to 0, which is 39.22 times 2 plus 39.22 times 4 plus 39.22 times 6 plus 39.22 times 8 minus REY times 8 plus 19.61 times 10 equal to 0, and we get REY equal to 122.5 kilonewton. Next, for the Fy equal to 0, 122.5 kilonewton minus 19.61 kilonewton minus 39.22 minus 39.22 minus 39.22 minus 19.61 plus RAY equal to 0, and we get RAY equal to 73.50 54 kilonewton. Next, we move to the final calculation for this part, which is calculate the internal forces of each member of the truss in this bridge project. As we can see here, this is our bridge project. So we have applied the joint method for this calculation to get the answer, which is we get the two different answer for the each joint, which is tension and compression. So that's all from me. Thank you.
Our project was to design a model railway bridge. Therefore, we have designed a railway bridge according to the dimension and specification already we have discussed. In conclusion, the model we have designed is a relative highly quality model because it has a good structure and is able to withstand high load. There are two recommendations. First, change element of the bridge with lighter system. A more efficient method is to replace the existing reinforced concrete slab with lighter solution such auto-torpedo steel decking, lowering the bridge safe width. This can lessen the deck's deep load, allowing it to take on additional structure capacity or alleviating overstress problem. Second, converting support span to continuous span. Engineer can also utilize a deeper continuous truss at the center support zone, which reduces the choke load. It should be impressive that such change necessitates a thorough examination of all aspects of the bridge, including the pier and foundations, which may require reinforcement. That's all from our group. Thank you.